Let us start with the simplest error detection mechanisms. This is called the parity scheme. The parity scheme uses parity bits. In this module, we shall first look at the simple operation of parity check. Then we are also going to understand its limitations. The references that I've chosen are Dimitri and Gallagher, the URL from computing.dcu.ie. These are the lecture notes, and a book by Michael Graves. If you look at the operation of parity scheme, it is nothing but adding only one bit to the data stream. If you have a file that is already in any octet representation, such as ASCII or extended ASCII, then implementing parity is easy. You take every word and append a 1 to it, such that if the total number of ones are either even or odd, that means adding one bit to it with a value of 0 or 1 is determined by the choice that you make. Let's look at the odd parity scheme first. Here you see that we have D data bits, and we want to implement the odd parity scheme. The odd parity scheme says that the sender appends either a 0 or a 1 in order to make the total number of ones odd. This is what you see in the figure on the top. Similarly, if even parity scheme is to be implemented by the sender, the total number of ones are to be made even. That is why we see that in the former case, the additional bit or the parity bit added is a 0, and in the later case, the parity bit added is a 1. It may be noted that the sender and the receiver have to be exactly on the same page. That means if the sender is implementing even parity, the receiver also have to implement even parity. If the sender and receiver are not implementing the same parity scheme, the interpretation of the parity bit would be different on both the sender and receiver sides. Apparently, the parity scheme seems to work fine, but the obvious limitation is that the parity scheme does not work for more than 1 bits going in error, especially if the number of errors that are taking place happen to be in even number. Because even if even or odd parity schemes are used, if the number of bits in error are even, simultaneously 2 bits are going to flip, a 1 changing into a 0 and a 0 changing into a 1, and resultantly the impact of the parity scheme is nullified. That's the first thing that you need to understand. The second obvious reason is that in a physical transmission medium, the errors happen in burst. So when the errors happen in burst, at one instance of time, multiple bits could go in error. Studies have shown that the probability of undetected errors in a frame that uses single parity scheme on real-world communication channels can go as high as 50%. That's a very large percentage. It means in real-world scenario, using single bit parity scheme is not the choice.